or negative? Okay, so you're gonna add. Or you do on one side of the equation, or do the other.
As you're working through those, one thing I just walked through and noticed there, please make sure you're paying attention if it's an equal sign or an inequality. You can't change it from one to the other. And no matter what we're doing, solving with an equal sign, an equation, or solving with an inequality, one more time, guys, nothing's changing there. All right, these should be pretty quick ones to solve out for. All right, so line down the middle, -1 gives me x to be
5.
It's a quick one-stepper. Over here, what's my inverse operation?
Add 2.
And on that one more
X
time.
equals 7. X is less than 7. Wait, no. Greater than 7.
One more chance there, Matt. Yep, there you go, bud. X is greater than. That's okay, Matt. You got it there.
My brain just focused on what it was doing.
So we got there, but please don't change that accidentally though to an equal sign. It's easy to do. We've been focused on equations, but that's what I do want you to caution out on. All right, and on this last one, how are we getting rid of that? What's my inverse operation here?
You times it by 3.
Thank you, Andrew. We're dividing.
And it's less than or equal to -3.
Right.
X is less than or equal to.
I got you, Andrew. So as we multiply by 3, and as we multiply by 3, that's all. Like that's all he wrote. Okay, that's nothing fancy. Those are all one-steppers. Now the last one I want to talk to you about. I want to see what you remember from your middle school years.
No.
Nothing. Andrew.
This is a -1 from the X, right?
So first off, x and by itself because there's a -1 out in front. Correct. Now, what is, that was a little large there. What is in front, or sorry, what is between that -1 and x? Correct.
A multiplication
And in the inverse of multiplication,
division.
so we're going to divide both sides by
-1.
-1.
Which would equal
X equals
x
greater than
is greater than -4.
Thank you, thank you, thank you. Now, one small thing here, though. All right, this is where I'm trying to see what you remember from middle school. Jayla said, not a ton. That's okay, Jayla. All right. When we are dividing by a negative here, we have to flip the inequality because that's changing it to an opposite sign on the other side. So we're flipping this around, and we need to flip around the inequality. We only do that is if we're multiplying or dividing by a negative, because what does a negative do with multiplication?
Flips it.
It flips it, correct. So a negative times a negative makes it a positive. It changes it to its opposite. A positive and a negative makes it its opposite, right? So what we need to remember for us to do here is, this is the only time that anything changes for us, is if we're multiplying or dividing by a negative, we need to flip the inequality. I didn't do it here. You didn't do it over here. We added, we multiplied by a positive. We didn't talk about flipping it. Here's where we flip the inequality when you divide by a negative or we multiply by a negative. That's it. Everything else is the same skills we've been focusing on the last couple of weeks, the last couple of years. All right, so that's what I wanted to remind you about on number 4. Now, some of it sounded like you reminded yourselves of that. So obviously we have talked about it at some point in our middle school years, but we're going to see some more of those here over the next couple of days. Okay, so let's flip it. Let's go to the next page. And on the next page, we're continuing where we left off with yesterday as we start off with. What did we start talking about yesterday with? Working with inequalities. Less than, greater than, less than, equal to, greater than, equal to. And what we did in there was some work with some word problems. So let's take a quick second, read in that little paragraph there. And what they would like us to do then is create a little equation, a little function here that is being represented here by Alan, and Alan's selling popcorn. Now, at some point, I'm sure a good chunk of you have done some type of fundraiser, either for the school, or for maybe some type of athletic team, or some type of extracurricular. If you haven't, no big deal, but here in this instance, as you're reading through there, Alan, he's saving up for earning money here for a camping trip, okay? So, in this one, it says Alan here already has what they say is a credit of $25 towards his sales. So maybe that means from last year, Alan has money saved over from his scouts from last year's money. And then he's going to go through and sell popcorn at $3.75 each. So that's how he's going to earn his money to go on a camping trip. So again, we've all seen these types of things before. Right now, during this time of the year, they're not doing popcorn sales, but Girl Scouts are doing what?
Cookie sales?
It's Girl Scout cookie time, right? So that's what's happening more this time of year with that Scouts. So here we go. We want to write an equation here for how Alan or you will be earning money for your camping trip. So how are you making money here? You're selling what?
Popcorn.
And how much popcorn did you sell? Did you sell 1 box, 2 box, 10, 20, 30, 40? How many boxes of popcorn did you sell? Do you know?
No.
And if we don't know how much popcorn you sold, that's what we're going to let it be. B is going to be the number of popcorn boxes they sold. That's what we're saying is defining the variable. So how much does each popcorn box sell for? $3.75 times B. Okay? You sell 1 box, you've sold $3.75. You made $3.75. You sell another box, you make another $3.75. You sell another box, there's another $3.75. Now, are we starting off at $0? Do you have $0 in your account?
No.
How much money do you have in your account?
$25.
So we're not starting off at 0. We're already starting off at plus, right, plus 25. Okay? So what we have right now going here is $25, and then we're adding on $3.75 each time for every many boxes Alan here is selling. And what's that going to eventually get you? That's eventually going to get you Alan's total, which they are calling F of B. And what F of B means, F of B is going to be representing his total sales. And that F of B is just calling it the function of the boxes. Okay? So, how do you earn money? Well, in this instance, we're selling boxes with a $25 credit. Right? Now, from there, let's come back around and talk about things that we talked about from first semester. You're making money by selling boxes. We want to identify the independent and dependent quantities, which we talked about one of the very first things here in August. So somebody, money, total sales, and boxes sold. Which one is the independent? Which one is the dependent? 25. We're talking about the sales and the boxes sold.
The sales boxes.
Which one's driving this whole problem?
The boxes.
Boxes is driving the whole problem, right? So when boxes drive the whole problem, that is independent. So our boxes is the independent here. So the independent is the boxes sold, and the dependent is the what? Total sales. The amount of money Alan raised. So again, if you're doing a fundraiser for your team or your club, whatever you're doing, that's what's going on here. Okay? If you're making money, cool. That's how you're making that money. Your money is dependent on how many boxes you sold. Now, that equation that we made should look very familiar to everything that we've been working with the last couple months. 3.75b plus 25. That structure of that problem should look like our ax plus b. Yes, we use a little bit different letters, but the structure of it is the same. What number here is representing our slope? 3.75 is representing our slope. So 3.75 is the slope. And in this instance, again, that 3.75 is representing 3.75 represents price, presents the price per box, right? So yeah, you're on the right track there, Andrews. With the boxes, we're in the price per box sold. Okay. And what's the last question there? And it says what number represents the y-intercept, right? 25. That ax plus b, that plus at the end there, or minus if it is, that is representing our y-intercept that we've been pounding on you since November, December, 6th grade, 7th grade, 8th grade. So our y-intercept in this case is 25. Now, in the problem here, in the context of this problem, what is the 25 representing?
Number sales.
It's not the number of sales. 25 was a what? It was a credit, right, toward our sales. $25 was a credit. It was already there. Credit towards Allen's sales. I should say Allen because it's not us. Allen's sales. Okay. So Allen again. Maybe this is the second year going on camping trip, and he had some money left over from the previous year. Or maybe at the beginning of the year, he had done another fundraiser and had $25 on a credit. So that's what maybe that $25 is representing. Okay. So he's already got $25 in the bank to send for it. And then he's raising money by selling popcorn boxes. Now, from there, the rest of these couple next pages is having a goal. If you're going to go on a camping trip, all right, and you're going to sell popcorn boxes, what's one of the first things you got to know? What's the cost of the camping trip? Not necessarily where is it going to be. You know where that's going to be, but what's the cost of the camping trip? And then it's going to be how many popcorn boxes am I going to have to sell to get to that cost? So that's my goal here.
Like how much the popcorn boxes cost?
We know how much they cost.
Oh.
We know they cost 3.75. Right. So let's look at the next page here. Okay, so they went ahead and they graphed it for us. They graphed our equation we made on the next page. So this scale, we said it on the second page. This is our independent right here. Independent is always the x-axis. The y-axis is always our dependent. Number of boxes sold, our total sales. And they graph that line for us. 25 is right here, our itty bitty credit that we have. And there's our slope, 3.75. And here's your sales goal for Allen. Allen's goal for his camping trip is $1,600. So what they want us to do here is try to figure out if your goal is $1,600, how many boxes is that going to have to represent? And we've done some of this stuff already. $1,600. Go find the point on that line. So $1,600 is right here.
40?
Take it straight down. And as you look straight down, yeah, this is that's the x-axis, that's the x point I want to find there. Unfortunately, my scale, I got to look at the scale here.
It's going up by 20, so...
Yeah, 120 to 240. That's a change of 120, 120, 120.
390?
Hold on there.
Wait.
So, hold on. 120. So these are split into 60s.
Oh.
So this right here, to go from here to here, that's a 60. So that's a 180. This is a 300. 360 plus 60. 420. Okay. So with that, then, when we drop it straight down, we've done this problem before. 420. 420 then on that one is going to be how many boxes? 420 boxes sold to make $1,600. And we've done that one already. We've done that one back in November, December when we worked with the linear equations. Okay. Now, looking at our graph there, we saw that sales had to be 1,600. Drop it down to the x-axis to see where our independent was at. Okay. Now we're going to represent that down there on our number line. It says use number line to represent the number of boxes sold. So we said you got to make 420 boxes. So let's represent that exactly at 420 boxes. So if we sell exactly 420 boxes, how much money do we make? $1,600. Alan's going on his camping trip. Okay? He's going on his camping trip. Okay? Now, let's flip it. Let's throw in some inequality words. So far, all we've done here is an equal sign. Now, as we look at the next page, on the next page, it says, all right, it says what part of the graph represents the line below the horizontal line. Okay? So we're talking about the part below the horizontal line. So I flip this back.
That's the X.
So, yep, below the horizontal line. We're talking if you sold less than 420 boxes. What does this region of the graph represent? Sold less than 420 boxes. And what does that imply then? If we sold less than 420 boxes, is Alan going on his camping trip? No. How much money did Alan make on $1,600? Did he make more or less than $1,600? Yeah. 420 is the magic number, right? If we've made less than 420 boxes, do we make that $1,600 mark?
No.
No. So what that also tells us is Alan made less than, whoops, spell, less than $1,600, which makes sense. 420 is like our bare minimum. If we make exactly 420, we're good to go. Alan's going on the camping trip. Now, if Alan does not make that minimum, he makes below that line, Alan's not going on that camping trip. How do we write that as an inequality? We just said less than. So X is less than $420. Okay? So what does that look like on our number line? Did we review that a little bit yesterday? Is that open or closed at 420?
Open.
Yeah, we didn't say equal to. We said just less than. So less than is open, and which way do we shade that? Left or right? Thank you. So if we shade all this to the less than of 420 left of that, Alan's not going on the camping trip. Now we talked about this yesterday. I think it was a school bus problem. And I said, hey, negative 25 students. Did we say negative 25 students made sense?
No.
No, because can we have a negative student there,
No.
Andrew? No, I know. So here, we shaded less than 420 boxes. Do all the solutions here make sense in the context of this problem? Can I have right here sold 3.5 boxes?
No.
Can I
Unless
sell?
you cut it in half.
Can I do that? No. Can I sell 2 1/4 boxes? So here in this problem, another thing to think about is, do all the solutions make sense in the context of this problem? No, because Alan cannot sell partial boxes. And what do I mean by partial boxes? Those fractions, those decimals.
What if someone takes half, like something that's in a box, but doesn't take by the box?
Can you sell half a box, or a third box, or a quarter box?
I mean,
I know what you're saying. Can we do that though? No.
now this problem.
So we can't sell part of a box. And in that goes right back to our negatives yesterday. Okay? Now I could have also said yesterday on our bus, I said negative 25 people, negative 25 students. I could have also said, instead of negative 25 students, I could have also said 13 and a third people. Do we have 13 and a third people on the bus? No, you can't have a third of a person. So those sometimes you got to think about, do they make sense in the context of the problem? And this one again does not. All right, let's go with the other one. It says, what about above the line? What about above the horizontal line? How many boxes do we sell above the horizontal line? So we're above this line. That means we are making, we are selling how many boxes?
Full boxes?
More than 420. So what we have going here then is sold more than 420 boxes. And what does that imply?
That Alan can go
Alan can go, and how much money did he make?
more than 1600.
He made more than 1,600. Okay? He made more than 1,600. Okay? So Alan can go and made more than 1,600. Alan can go and made more than $1,600. Okay? So 420, that's that sweet spot. We make 420, Alan's for sure going. But if he can make more than 420, sell more than 420 boxes, he's definitely going. And then he's going to have some maybe extra spending money or something like that to go with. Okay? So, off of that, what inequality goes with the word more than? When we say the word more than, what inequalities go with that? Not just equal to, but also just really, I should say, actually just greater than. Okay? Because more than does not include the word greater than, equal to. We're just you get above it. You're welcome. So we're just doing x is greater than 420. Okay? So x is greater than 420. Alan sold more than 420 boxes. Okay? All right, let's go put that in a number line. Go graph it right below there. 420, right below that. Is that 420 going to be open or closed? Okay, is that 420 going to be open or closed? Open. It's going to be open because there's some people too. Where is it? It's just going to be open. And are we going to shade left or right off that? We're going to go to the right because you said greater than, didn't we? So we are selling more than 420 boxes. All right. So 420 boxes sold. Boom. We're going to the right. There's nothing left there, so I'll just toss it. Actually, save the bucket. We'll save it. I can put it on some kid's head. Something like that. Nothing, Matt. All right. So from there, okay, one more time. Why does that not make sense, though, to necessarily shape every single thing? Because I can't sell 430 boxes. I can't sell 450 and a half boxes of popcorn. So we're going to copy paste down the same answer we said earlier. Right here where we said no, because Alan cannot sell. No, because Alan cannot sell partial boxes. Okay, so what I've shaded here was like 300 and a half. 300 and a half, or sorry, 500 and a half cannot happen. 499 is fine.
That's exactly.
Okay, but really we can't shade everything. Jasmine? Jasmine? Oh, yeah. We'll put you in line here. Give us a second. Okay. All right. Let's flip. Let's go. Now on the next page we go. What are we using the difference between open and closed circles? So when do we do the open circles versus the closed circles? Open circles happen when? Open circles were happening when? When in the open? Right. Those were happening only with is less than, is greater than. It did not have the or equal underneath, as Jalen just said. Right, the line underneath. Those were the symbols where that's using, right? When do we have the closed circle? There we go. With the closed circles, it's when it does have the line underneath. It does when it says or equal to. So when we do use the closed circles, we do have is less than or equal to. Or we do have is greater than or equal to. Okay? So those are the symbols of where we're putting those close. All right? Again, talked about those yesterday, started reviewing those. Okay? Alrighty. Now, the last bits and pieces that we're going to see here today, we're going to change around Alan's goal just a little bit. Maybe somebody donated some extra money for Alan's camping troop here. And here, Alan maybe doesn't have to get $1,600. Here, it says Alan actually only needs to earn at least $925. What's that going to look like in terms of our modifying our equation? Now, modifying that, what was our equation here Alan was using? $3 and what was it, 75 or 25? 75, thank you. $3.75 a box plus a $25 credit. His goal is $925. But it says it needs to earn at least. At least is not the same thing as an equal sign. At least is an inequality. So here's all of Alan's total sales happening. He needs to earn at least $925. At least goes with an inequality. You got to know your vocabulary. When we say the word at least, which type of inequality symbol does that go with? Does that go with a greater than symbol or a less than symbol? Correct. And I hear that word at least, and I think at least maybe goes with less than. It's actually going to go with my greater than or equal to. I get at least make $925. But if I make over $925, even better. $925 is my minimum. If I make $1,000, even better. Make $1,200, $1,600, $2,000, even better. But if I make below that, that sucks. If I make $900, $800, not good. So On letter A here, we modified it just a bit. We took out the equal sign, and the word at least means greater than, actually. All right, let's solve it out. Now we're back to using our equation skills, guys. Solving skills. This is where your calculator comes into play a little bit. Solve out for B. What are we going to do to solve out for B? Solving out for B, well, what are you going to move first? 375 or the 25?
I don't even know what to do.
Solving for B, Andrew. We're going to solve for B, solving for B. Move the 25 or the 375? Okay, we're going to move the 25. So we're going to move the 25 here. When we solve out here, this is going to tell us how many boxes Andrew is going to need. I say Andrew, Alan, I meant to say. 900. 925 minus 25 gives me 900. And then we divide. Divide. Now this is where your calculator would come into play, because dividing that is not very nice. Where I'm doing multiplication, just like we've been doing and doing and doing. And we're not flipping this inequality. 900. Yeah, that was some work we were doing earlier. 900 divided by 3.75. That means Alan needs to sell at least 240 boxes. If Alan sells at least 240 boxes, Alan makes his new goal of $925. And think about it, that should make sense. He had to sell 420 boxes to make $1,600. Less money requires less boxes sold, right? So that makes sense. He's got a new goal. How many boxes does Alan have to sell to earn less than 2050? So 2050, that's quite bigger than 1600.
So we're still going to do this.
Same solving though, yeah. 375B. The only thing that's changing here for us is our goal of 2050. And now it says less than. And I'm going to use my less than symbol. I want to be less than 2050. So if I go over 2050, what does that mean? It means I get nothing more. Like if I sell over $2,050, I don't get anything special. All right. So no reason to go over $2,000 there.
Or the tax man's coming.
Or maybe the tax man coming. It's that season starting. Yeah. Subtract 20. Nothing changes. We're still going to subtract 25. It's just that we're working with a new number here. 3.75. And we're still dividing because, well, it's still multiplication, and the inverse of multiplication is division. So we cannot sell more than whatever 2025. Whoops. 2025 divided by 3.75 is 540 boxes. Again, that should make a little sense because we are larger than $1,600 this time, so we need more than 420 boxes. 540 boxes gets me to that goal. If I go over 540 boxes, it doesn't get me anything extra. If you've been in Scouts or something, my son is in Scouts. If you reach certain places, you get certain extra incentives. But maybe that's the max, and there's nothing after that. Okay, no reason to sell past that. And then the last one, the word exactly. What comes to mind when you say the word exactly? Right, equal to. Exactly, the equal sign. So using the vocabulary tells us, again, what either inequality or in this case equal sign to put there. 700. Now based off of what we've seen so far, based off of 540, 240, the totals, what type of boxes should I get for 700? More or less than what we've had so far?
Less.
So let's find out that less then. So still the same thing. Alan's boxes aren't changing. Alan's equation ain't changing, except it's going to be equal to 700. So Alan's going to go for the bare minimum. We know how that is. If he sells exactly $700 worth, he's good to go. Alan is going to go for the exact bare minimum. Alan sells the exact bare minimum. He is good to go for the camping trip. He's not going to put in any more effort than what he has to do. Okay? So he's figuring out what is that exact bare minimum. 675 divided by $3.75. That's where your calculator is coming into play. And Alan, if he sells exactly that amount,
180.
180 you said? So checking that with there, I agree with you there, Jalen. If he sells exactly 180 boxes, Alan is done selling his boxes, and he's good to go for the camping trip. So he's good. 180 boxes sold, good to go. Okay? But the vocabulary is what's doing us for there. Nothing else is really happening differently. We've talked about creating equations. We're going to create even more equations, and then our solving skills. Those are all still the same thing. Okay? All right. I think that does that. Yep, it does that. All right? We'll talk about more of that tomorrow, which is nothing major because we've continued to do the same stuff we've been doing. Okay. That's what we're going to pause those things.